So now we're going to continue with part 2 of this practice final. This is the atom section. So number of protons and neutrons in carbon 14. 14 is the mass. So mass includes protons plus neutrons. So the answer would be 14. The number of protons in carbon 14. Well, carbon on your periodic table has an atomic number of 6. I'm going to trust you to look for that. That's 6 on the periodic table, and that's the number of protons. So the answer is A. Number of neutrons, we know protons plus neutrons equals mass, so if you know that there are 6 protons, pretend that's not there, we don't know how many neutrons, put a question mark. We know it's supposed to equal 14, so there must be 8 neutrons. Because 6 plus something equals 14, so the something has to be 8. Smallest unique part of an element, would be an atom. You see, electrons and protons and neutrons are all smaller, but they're not unique to a particular element. So the key word there was unique. So the answer is A. Nucleus is given a charge by the protons. So the nucleus has protons and neutrons in it, but those are positive and those are 0. So the charge comes from the protons. An isotope is a specific element. Keyword specific element, so its protons can't change. Its electrons can change if we call it an ion, but it's not an ion. Although on the actual final it might say ion, so be sure you're with it on that. An isotope has a varying mass, but it's not a number of mass, so it's not varying. That's the crazy answer. So neutrons and mass is our answer. Neutrons change, and that causes the mass to change. Okay, this one here has a little answers got repeated by mistake, so the answer is low density. The electron cloud is negative and low density. So the answer is either A or D, either one. They're the same. The mass of the atoms contained in a pinpoint center called the nucleus. That's absolutely right. That's B, true. Because in the nucleus are the protons and the neutrons. And they each, that's supposed to be a C, each have a mass of 1 atomic mass unit. Electrons, 0 atomic mass units. They're so small. And if they're the same element, they're going to have the same number of protons. So which one of these means number of protons? Atomic number. Whoops, didn't do so well with that arrow. Atomic number. All right, which of the subatomic particles are not in the nucleus? Well, protons and neutrons, we just said, are in the nucleus, so that leaves electrons to be outside. And the mass of the atom, I just told you that too, is in the nucleus, so it's protons and neutrons. The subatomic particles that are in energy levels outside of the nucleus, we already just talked about that, be electrons, and the subatomic particles found in the center of the atom would be the protons and the neutrons. Now what's more involved in bonding? That'd be what's on the outside. So that'd be electrons. All right, 27 to 36. On this chart, you got lithium 7, so you know the symbol is lithium. The atomic number for lithium on the periodic table is 3. That tells you that its protons are 3, and its electrons are 3 if there isn't a charge. I don't see anything that indicates a charge here, so that'd be 3. Neutrons, we know the mass is 7, because it tells us right here it's 7. So the neutrons would be, remember, protons plus neutrons equals mass. So if the protons are 3, we don't know what x is, the neutrons, that equals 7. So 3 plus something equals 7. Magnesium, if you look at your periodic table, will have an atomic number of 12. So we have 12 protons. And the mass number of that would be, let's see, do we know the neutrons? Yes. Protons plus neutrons equals mass, so 12 plus 13 equals 25. So that'd be 25, and then you write the hyphen notation. Magnesium 25. Now we're going to do arsenic's electron configuration. Arsenic has 33 electrons on the periodic table, so you'll see 33 is arsenic. So 1s, 1, 2, 2s2, 2p6, 3s, 3p, 4s. Notice the order. Then after 4s is 3d. Notice I'm putting them in one at a time before they pair up. Okay, that's 30 electrons. We need to go to 33. So you see I got 32, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 31, 32, 33. So the full electron configuration in the 1s you have 2, in the 2s you have 2, in the 2p there were 6 of these arrows over here. Then in the 3s over here there's 2. Then in the 3p there'd be 6 again. Then the 4s was next, and it's over here 2. And then the 3d 10. And then the 4p supposed to have 6 but only had enough to have 3 in this case. So 6 is its max, but it can have less. The outer shell is just that and that. So it'd be 4s2, 4p3. Notice that'd be 5 in the outer shell. Right there they are. But the outer shell configuration is just 4s2, 4p3. The noble gas configuration, you'd go back to the previous row, this previous series above arsenic. So if you're looking at a periodic table, you can see that that's argon. So you write down the configuration of argon, and that includes 18 of these 33 electrons. So 2, 4, 10, 12, 18 goes to right there. So what's left over is the rest of the noble gas configuration. And now this chart has some charge on it, so we'll deal with that. Nitrogen is 7. Tells us right here the mass number is 15, so just going to put that in. Protons never change. That's got to be 7. Atomic number equals protons. Now protons equal electrons unless there's a charge. So P equals E unless there's a charge. Is there a charge? Yeah, -3. Does that mean you've lost or gained? So gain electrons equals negative charge. Negative charge. So you got -3 means you gained 3, so now you have 10. Because 7 plus 3 is 10. And then remember, protons plus neutrons equals mass. We know 7 plus x equals 15, so x must be 8. All right, next row, we got 14 protons is our giveaway. So 14 protons, that means your atomic number is 14. If the atomic number is 14, you know it's silicon. Its mass number, it would be protons plus neutrons equals mass. Do we know the protons? Yes. Do we know the mass number, or the neutrons? Yes. So 14 plus 15 is 29. And we also know the mass number for another reason. It says right there. Electrons. It says a positive 4 charge. So have you gained electrons or lost electrons? So loss of electrons. I should just say lose electrons, but anyway, a loss of electrons. Lose electrons equals a positive charge. So you've lost 4. So you used to have 14 electrons because protons equals electrons unless there's a charge. So you normally have 14 electrons, but you lost 4. So now you got 10. All right, I might remind you that this is on there, and I'll try and put this on the table, on the final also. So be sure you pay attention to that little statement. All right, that's that end of that section.